Hello everyone, today in this video I'm going to share you about my experience in OASIS INFOBYTE internship, and I've been given 5 tasks, and let me walk through you one by one. And I'm making it as a single video rather 5 short videos, and I guess I'll be posting it into LinkedIn. And okay, so let me go into the first one, which is IDIS. Which is on IDIS dataset. Actually, it's a pretty like a basic dataset, and what we do is we import all the necessary libraries, and there are 4 features in this dataset, which is um, by which we classify the flowers into their species like Setosa, Virginica, and another vesicola. So these 3 classes of plants are present, and we have to train a model that classifies the flowers into their species with respect to the 4 features given. And so I have split the dataset into train and test datasets, and I have kept the test size as 25%. That is, the model will use 75% of data to train and to take the remaining 25% for to test the accuracy of the decision of the model. And so in this example, I'm using decision tree classifier, and I've used the train data to fit and train the model. And now I have used the train model to predict the test value of the test data of X, and we have got a new the prediction class, and now we are comparing the prediction class with the actual class, and we are trying to find the accuracy of a model, and it is around 94.74%, and now we are plotting it in confusion matrix, and we have shown the visual representation of the tree, and I also used another model which is a Gaussian NB. Gaussian NB basically uses the probability of each value and how likely it is to affect affect the outcome of the model. And so if you have 3 classes in this data set, then the model would take each feature we provided and it will check the likelihood of that feature to the class, and it will assign the class which has the highest likelihood to our X values, and it also gives us a value of 94, and we have plotted it into a confusion matrix. And the second one, I was given to analyze the employment and unemployment rate in India. So it was just an analysis. So in an analysis, it was to go as many plots possible, and I'll just show the data set here. And I've named, like, the names weren't like, there was some dot in between and there was like brackets, and so to remove that, um, named it with my own columns, and it's a shape of 9 features and 267 rows are present, and everything is normal. Okay, so what I did first was I made new columns that contains date and month, and I'll be using data. So what I did is, first I take the month and I group the data by the month, and I show the mean values of the estimated unemployment rate, estimated employed, and estimated labor participation rate, and then I used the bar plot to show us on basis of each month how good they are, how the unemployment rate is present, which is the blue one, and the labor participation rate. Each the mean of the rates in each month is usually represented, and I also used another plot from January 2020 to October 2020, and the other one I used was in the previous one we have used grouping by months, and in this I have tried to group it by the states. And okay, so in this plot we can plot based on the longitudes and latitudes given in the dataset, and we have a slider here through which we can slide and see the variations between each month, and each state is defined by a color, is represented by a color, which makes it easier for us to understand. So next, let us take a look at the car price task. So in this, we are given with a CSV file that contains a lot of details about each car, and through which we can, and the price of the car is also given. So we must find a way to relate these features given to the actual price, and so I'm processing it a little bit, and then what I do is I use a standard scaler, and the reason why I use this scaler is that there might be different values. Each column might be in a different scale, and so when we compare it, just because the scale is higher in numeric, like in its value, should mean that it is related more to help us predict the car price. So what I do is that I just scale all the values to scale, like we in the standard scale I use z-score normalization, which is through which we can achieve everything in a similar scale from some negative like -3 to +3, maybe negative is more characters, but it will be easy for us for the model to predict the price. So I'm again training and splitting the data, and in this I use a linear regression model, which is actually trying to fit a line. I'm trying to make out an equation through which we'll be able to find new values, and so in this we will not be able to use accuracy score, and the reason why is that this is a regression, this is not a classification. Like if there are discrete values in a target column, then it would be known as classification, but in here we are having like we have continuous values, so the metric to evaluate this model is mean squared error. So as I said, the regression being done here, and I'm listing the values. Okay, so let's jump on to our fourth task, which is spam mail. It's like the most interesting task. And what is done, what has been done here is I'm importing and I'm reading the CSV file. It has some message, and it is classifying the message to if it is a spam or if it is not. Like the ham refers to this, it is not a spam mail, and then I group by. I'm just analyzing the data, and here I'm using a label encoder. What the label encoder will do is that if we have discrete values, it will encode a numerical value to each of those strings, which will be helpful for us. And splitting the data, and here I'm using a count vectorizer. So what is a count vectorizer? Count vectorizer, what it does is it takes the unique words in all of our messages, and what it forms a vector in which each element refers to a word, a unique word that we have found, and if it is one then it refers that the word is present, and if it's zero, it refers to the absence of the word. And so we so for each message vector, we make a vector, and we put all of those words in, like one, or if it's present we put one, or if it's not we just put a zero. And then we are using the name bears like we did before for the IRIS, and we are training it by the train model, I mean the train data, and we are testing it by the test data, and we are getting an accuracy of 98.30%, and we're just having a function to predict if it's spam or not. So like when we run this predict, it gets an input from us, that is a spam. We should give a message like um, we should input the model a message, and what it will do is that it will convert it into a vector like we did using the count vectorizer, and then it will feed it with the model, and it will um, and make sure if it is a spam or not, and it will display as results. So let us move on. Um, the last one is sales prediction, and I'm importing and I'm reading the data. So that this data is actually like we are having the amount like on percentage. I don't exactly know what scale it is, but we are having how much um, consideration is taken on TV, radio, and newspaper, and how much it is given as sales. So we will be finding the relation between each feature with respect to sales, and we will use that to find the relation to predict the sales. And so we are taking X, and we are having a target Y, just the sales, and we're just plotting the TV advertisements to our sales, and then we are visualizing how the radio advertisements are scattered over the sales. And from this you can see like more number of advertisements gives us a lot number of sales. It's the same case here, but also at some cases more advertisement of radio, which is 50 gives us not that much. It might give a lot, but it also might not give you. So it will be respect to other columns, and mostly um, they're not. They're yeah. It is like everything is scattered because we cannot decide with a single feature how our sales will occur. So I'm standard scaling, and as I said before, to convert everything to the same scale, and then system putting I'm putting a linear regression model that I've used before, and then I'm just using it to predict the test data, and I'm comparing. As I said before, here too we have to use a mean squared error metric as it is a regression. So I thank OASIS INFOBYTE for providing me this opportunity, and it was really fun doing all of this, and um, keeping it in a repository, and I will be sharing the repository to, and I really take this moment to thank OASIS INFOBYTE for this opportunity, which helped me learn a lot of new things. Thank you so much, and I assure you that I will make use of the knowledge that I've gained in this for better purpose. Thank you.